passes through the 2 points, 2, 5, and 6, 11. So this is like we did yesterday. So take a moment, see if you can remember how do we find the slope, what formula do we use, and how can we go about this. Okay, so when solving this, we're going to use our formula y2 minus y1 over x2 minus x1. So if we look, our y2 from our equation, we have 2, 5, and 6, 11. So our y coordinate of our second point is going to be 11 minus y1 is 5 divided by our x2 of 6 minus our x1 of 2. So if we solve this, 11 minus 5 gives us 6. 6 minus 2 gives us 4. And then we can reduce this fraction. 6 over 2, we think both of these are divisible by 2. They're both even numbers. 6 divided by 2 is 3. 4 divided by 2 is 2. 3 halves cannot be reduced. So that will be our slope for this problem. Now, as we continue throughout the day, if we think about the linear equations, they're always written as y equals mx plus b. Now that slope, that's our m. We just figured what that out was. But we still, when given 2 points, we don't know how to find that b. So that's what we're going to focus on today. We know how to find our slope. How do we solve for that b? So given 2 points, we can find the equation of that line that passes through those points with ease, and we can find all of our information needed for that line. So let's stick with this situation. So we're given the slope between 2, 5, and 6, 11. We just learned that that was 3 over 2. Now we want to try to find what that y-intercept for this problem is. So like we said, we know it's going to be y equals mx plus b. That b, that's our y-intercept. So in order to solve this, we need to utilize the information we're given. So we know our slope. So far, we've already told our slope was 3 over 2. In order to solve for b, though, in order to solve for that y-intercept, we can't have any other variables in this equation. We can't have that y, we can't have that x. So we need to do something to get rid of those variables in order to get just b to be able to solve for that. So if we look through our problem, and we think, okay, what x's and y's were we given before? Well, each of these points is made up of an x and a y. So rather than just having to think of 2 numbers to go in there, we're actually given 4 numbers. But the thing is, whatever I choose for my x, I can either choose 2 or 6. If I choose 2 to replace my x, that means that 5 has to go in for my y. If I choose 6 to replace my x, that means 11 has to go in for my y. But I can choose either of these 2 points. It doesn't matter which one you choose. Either of them will work. I can choose 2 or 5 or 6 and 11. I just have to make sure I'm consistent with my points. So I'm going to go with my smaller 2 numbers. So I'm going to choose 2 and 5. Smaller numbers are typically easier to work with in this situation. And so I know my y is 5, so I'm going to change 5 to y, and then it's 3 over 2. Then my x, I'm told, was 2. So plug 2 in for x. Now, I have completely eliminated all of the variables except for the one I need to solve, except for b, that y-intercept. All I have to do is simplify and solve, and then I'll be done. So if we think, first things first, we need to do our multiplication. 3 over 2 times 2. If I think about this, this is the same as 2 over 1, and then we can think of fractions. When multiplying fractions, you multiply straight across. 3 times 2, and 2 times 1. So this is 5 equals, we'll write down what I have above. Now 3 times 2 is 6. 2 times 1 is 2, plus my b. Now 6 over 2, I can reduce that, I can simplify that. 6 divided by 2, that's the same as 3. So this leaves me with 5 equals 3 plus b. Last step, all I need to do is get that b by itself. I need to get rid of my constant, so I need to inverse 3. So I'll subtract 3. And I'm left with 2 equals b. So I have my y-intercept. Thinking back, I already have my slope. So I have everything I need in order to write the equation of this line. So I know my equation is always going to be y equals m plus b from before. So it's going to be y equals m is 3 over 2, my slope, x plus my new b I just found of, what do we find it was? 2? Yeah, 2. So y equals 3 over 2x plus 2. And that would be our equation. So let's look at another example of that. That was a lot of stuff to do just at the moment. So let's look at another example of right here. So we have find the slope of the y-intercept of the line that passes through 6, 24, and 10, 4. So you know how to do the first part. You know how to find the slope. So take a moment, see if you can find the slope of this equation, and then we'll reconvene from there to do the second. All right, so we found our slope. We were able to see that 4 minus 24 divided by 10 over 6 becomes negative 20 over 4, which gives us negative 5 when reduced. So we have our slope. Good, awesome. Now we need to think, okay, I need to figure out what my b is. What is my y-intercept? So I know my function is going to be y equals my slope. I just found that, negative 5, x plus b. In order to simplify this, in order to solve for that b, I can't have a y, I can't have an x. I need to get rid of those functions, or I need to get rid of those variables. So I need to think, looking through my information given to me at the beginning of the problem, what x's and y's was I given? So I was told that x is 6 and y is 24, or that x can be 10 and y is 4. Those were my x and y's. Those are my coordinate points I was given that's on this line. So because I know these points fall in my line, I can input them in for my function. I'm going to once again choose the smaller numbers, 10 and 4. I'm going to replace my x and my y with those numbers. So let's see, y equals 4. So 4 equals negative 5 times x, which I was told was 10, plus my b. All right, in order to simplify, same step. Multiply these two numbers together. Negative 5 plus 10. That's going to be negative 50 plus b. That equals 4. All right, I need to inverse my constant, plus 50. Add 50 both sides. That leaves when b equals 4 plus 50 is 54. So I found my y-intercept, it's 54. So I can go back up, and I can rewrite my equation in full. Y equals my slope of negative 5x plus my y-intercept of 54. Awesome. That's all we need to do. All right, so on this next one, take a moment, see if you can. Oh, sorry, that's not one. We're gonna do. So take a moment, see if you can first find the slope between these 2 points. And then, once you find your slope, see then if you can, what is going on? Find the slope, and then find your y-intercept. Last step, write your equation in full. So y equals whatever your slope is, plus whatever your b is, right? The equation, that's not how you spell equation, but, and you get the idea. Write the equation in full. All right, take a moment, see if you can do it. All right, so welcome back. It's like you were able to do it. So we have our slope. The first thing we did was we did that y2 minus y1 over x2 minus x1, 12 minus 8 equals 4, 5 minus 3 equals 2, 4 divided by 2 equals 2. Second step, we needed to find our y-intercept. Now that we have our slope, we know it's going to be y equals 2x plus b. We can replace that y and we can replace that x with some information that we're given to solve for b. So I took 3 and 8. Those are my smaller numbers. So I put 8 in for y, 3 in for x because that's my x and my y coordinate. So 2 times 3 gives me 6. Minus 6, so I can invert my constant. 8 minus 6 gives me 2. So b equals 2. Last step, rewrite my equation with all my new information. I know my slope is 2, my y-intercept is 2, so y equals 2x plus 2 is my function. All right, so now we have a better understanding of how to solve for our y-intercept, how to use those 2 points to find all the information given to get this equation. We're going to look at what happens when we're given a situation. What happens when we're given like a word problem? So we have a climber, and this climber is on a hike. After 2 hours, he is at an altitude of 400 feet, and after 6 hours, he's at an altitude of 700 feet. What is the rate of change? What was his altitude when he started? So rate of change, this is just another fancy word of asking for slope. What was the slope of our climber? As long as it's a linear function, it should have a slope. Rate of change is more of a word that's used in situations. When you're given a word problem, they might ask for rate of change. When you're given like a linear function, like with actual points, they're probably going to say slope. But we want to know those words are synonymous. They mean the same thing. Rate of change and slope are the same thing. So we first want to find the slope. But in order to find the slope, in all of those last problems, we were given 2 points. In this problem, we're just given a bunch of information. We don't have those points. So we need to figure out what those points are first, and then we can find our slope. So we need to think, what is an independent variable? What is a dependent variable? What's going to be my x? What's going to be my y? So in the past, your independent variable, that's always been the thing that can sort of stand on its own, changes on its own, and when that changes, your dependent variable changes along with it. So your dependent variable is sort of affected by your independent variable. Now, independent variable, almost always, if you're given a time, you're given a time frame, so in this case we're given hours, that is almost always your dependent variable. 90%, that will be your dependent variable, or independent variable, I'm sorry, I said that. Independent variable. So we know hours is going to be our x-coordinate, so 2 hours is 1 x-coordinate. I'm also told another x-coordinate of 6 hours. Now at 2 hours, my hiker is at 400 feet. So the altitude of my hiker is changing based off of how far he's hiked, how long he's hiked. So after 2 hours, I'm at 400 feet. So that's my dependent variable. My altitude is my dependent. And this is 700 feet after 6 hours. So now we've taken that information. We found our time, we found our height, our altitude, our y, our dependent variable. We plug those into our function, or plug them into coordinates, made 2 coordinate pairs out of them. And now we need to find the slope. So once again, we're going back to our steps that we've done before. y2 minus y1 over x2 minus x1. So that's 700 minus 400 over 6 minus 2, not 4. So we need to solve this. 700 minus 400, that's going to give us 300. 6 minus 2, that is 4. So we need to think 300 divided by 4. You might be able to use a calculator, you might have to bust that out, but that will give us 75. That's our slope. All right, so we solved one part of this problem. Now, the second half of the question asks, what is his altitude? Actually, let's go back to slope. What is his rate of change? And we want to add a little bit extra to this, a little bit extra to the context of the situation. Rate of change is typically something over something. So slope is rise over run. Rate of change is what is our dependent variable divided by our independent variable. So when we think rate of change, that's like your speed. So what was the speed of this hiker? What was his altitude divided by his time? So it's 75 feet per hour would be his rate of change. So he's gaining 75 feet every hour he walks, or every hour he climbs, every hour he hikes, or whatever he does in this situation. So that's our rate of change. All right. Now think, what was his altitude when he started? So we have to think. All right. When did he start hiking? And it might be easy to think, okay, he started at the ground. He started at 0. But that's not in every situation. Because, for example, your altitude when you first start climbing a mountain might not be 0. It might be, you might start a little bit higher up. We don't know. We don't know when he started this hike or where he started this hike. So we have to try to use the situation to figure out what that function or what that initial value is. What if we think back to earlier when we learned how to find linear functions and we learned how to create them from situations? We use that same formula, that y equals mx plus b. We knew that slope, that was how much something's changing by. What's that consistent rate of change that's happening? That y-intercept, though, that was always our initial amount, our starting value. So, if I can spell initial right. Initial. That was always our initial amount. Okay, good. So that's always our starting value. So we just learned how to solve for this y-intercept. If we can find that y-intercept, we can find what was its altitude when we started. What was that initial amount? Where do we cross that y-axis at 0 on our function? So all we need to do is do just like what we did in those last 2 problems. Set up our equation, plug in something for our y and x, and solve for that b. So we know it's going to be y equals 75x plus some b, some initial amount I need to find. I need to use one of my 2 points. I'm going to use 2 400 just because that's a smaller number. So 400 is my y, and 75 times 2 is my x, plus b. 75 times 2, if I think 75 is 3/4, and I double those, I get 6/4, which is $1.50. Plus b, that equals 400. I then need to subtract 150 to get e by itself. That'll cancel out. Subtract 150. 400 minus 150 leaves me with 250. So our hiker had an initial height, an initial altitude of 250 feet. So anytime you're solving for an initial amount, anytime you're still looking for a starting value with one of these functions, figure out what that y-intercept is. What does that be? If you need to, use those 2 points to solve for it. If not, if you're given in the situation, then just write it down. But always we need to start with our slope and then find that y-intercept. So this is where we'll start or stop for today. We'll continue to practice this tomorrow as we learn and continue to practice solving for that y-intercept, specifically with points. But then we'll start throwing in those situations. What happens? How can we find those words? How can we change those words into points? And we'll start practicing with that tomorrow. Okay. Okay.